Hello, and welcome to today's webinar on compressed air, brought to you by Plant Services and Quincy Compressors. I'm Tom Wilk, the Chief Editor of Plant Services, and I'd like to express my appreciation to you for joining us today. This webinar is sponsored by Quincy Compressor Incorporated, a leading designer and manufacturer of reciprocating and rotary screw air compressors, vacuum pumps, and a full line of air treatment components. Before I introduce our speaker for today, there are a few housekeeping issues I'd like to review with you. On your screen, you should see several primary sections. The upper left, or audio control section, allows you to adjust the volume of the presentation. Just hover over this section with your cursor until you see the audio volume control and adjust it to your preference. To the right, in the largest section, is where today's presentation slides will be displayed. Under that slide window, you will see a chat section where you can chat live with fellow attendees. To the left of the slide window is the Q&A box, and this is where you can type questions for our presenter at any time during today's webinar. We'll get to as many of those questions as we can during the live Q&A session following the presentation. And those questions that we don't get to, Scott will also address with you offline. Also, the handout section at bottom left contains links to several resources, including the full set of today's speaker slides and a white paper on isentropic efficiency and specific power. Finally, near the bottom of your screen, you should see icons for additional features. By hovering over each icon, information about the icon will be displayed. If you have any technical problems, you can type in your question or concern in the questions and answers box, and one of our technical engineers will assist you. If you need a better view of any section, especially perhaps the slide section, you can enlarge those sections by clicking on the box in the top right corner of the section next to the X. If you accidentally close on any sections, you can get them back by clicking the restore icon near the bottom of the screen. It's the leftmost icon in the shape of an arrow in the shape of a circle. This webinar will be archived, and we encourage you to direct coworkers to the recorded presentation. Finally, at the end of today's webinar, we'll ask you to complete a very brief survey to provide some feedback we can use to improve these webinars. And now I'd like to welcome Scott Barker, who will present on the topic, Federal and State Regulation of the Compressor Industry. Scott is Business Line Director for Rotaries and QAS at Quincy Compressor. He holds a Bachelor's in Mechanical Engineering from Purdue University and a Master's in Business Administration from Auburn University. Welcome, Scott, and thanks for presenting today.
Thank you, Tom. I'm pleased to be bringing the subject of federal and state regulation for the compressor industry. I'm going to cover a few of the things that you're going to learn during this webinar, some of the key implementation dates, what range of compressors and type of compressors are covered, how specialty purpose compressors are going to be handled by the new regulations, what are some of the key metrics and test methods in with the new legislation. Some other questions that will be answered are new efficiency terms, what they mean to you and your fellow practitioners, why the new guidelines are more conservative and transparent for average users, why compressor companies don't want to change to the new rules, and where to access additional reference materials from official government websites. Some of the dates, starting out in December 31st of 2012, the DOE issued a notice of proposed determination of coverage. Basically, that meant that they were notifying the public that they were going to be covering industrial air compressors as a regulated equipment. On February 5th of 2014, a notice of public meeting was published in the Federal Register. May 5th of 2016, the DOE issued a notice of a proposed rulemaking. That's where we first learned about some of the specifics of the new rules. Now, in November of 2016, the DOE published a notice of a final determination which determined that the coverage for compressors was necessary. And then on December 1st of 2016, the DOE issued a test procedure final rule. Within this rule, what was the covered equipment? Air compressors, rotary style, not liquid ring compressors, driven by an electric motor, and lubricated compressors. Compressors having a full load operating pressure between 75 and 200 psig, and that are not designed to the requirements of API or the American Petroleum Institute Standard 619. To go into further detail, it's compressors from 10 to 200 horsepower or 35 to 1,250 cubic feet per minute, CFM. So as an additional, rotary compressors, air compressors, liquid rings are excluded. These are electric compressors. Oil-free is excluded, so it's lubricated only, 75 to 200 psi, and API equipment is excluded from being covered. Anything outside of the 10 to 200 horsepower and 35 to 1,250 CFM is not covered by the regulation. There was specific language about specialty purpose compressors. DOE established 3 very specific criteria that the model need to have distinguishability, that it's not derived from a general purpose compressor, must have currently make public representations for that specific category of compressors. And the third criterion is that it must be impractical to apply the test procedure to the compressor in that specific category. So what does all this mean? Exclusions are very difficult to justify and achieve. The most important and new metric for measuring, publishing, and comparing industrial air compressors is called package isentropic efficiency. Now, isentropic efficiency is a ratio of theoretical power required to compress an ideal gas from the inlet pressure to the stated pressure to actual power required. It's always less than 100% due to friction, heat transfer, and thermodynamic irreversibility of compressed air. So it's a direct percentage comparison, 70% versus 80%, 80% versus 90%, with the higher percentage being more efficient. Isentropic efficiency, which can be calculated and measured independently of compression technology, is not a measured value. It's not directly measured. It's derived from power consumption, pressure ratio, and delivered capacity. So there is an equation to calculate isentropic efficiency based on some other measurements that are taken. In conclusion, isentropic efficiency is a direct comparison between 2 compressors as a percentage, with 100% being perfect or theoretical compression. And it is a measure of how efficient that compressor is compared to the theoretical perfect compression. In order for an isentropic efficiency to be meaningful, it's essential that both the ideal and actual work values be calculated or measured at the same operating pressure. For fixed speed, this is one isentropic efficiency number. One number, 72% versus 76% as an example. For variable speed, this one number is a weighted average of 3 different points, or standardized load levels. For this is 40%, 70%, and 100% of the full load. So you will have one isentropic efficiency number for fixed speed and one for variable speed. And variable speed will be made up of 3 weighted average part load points and will produce 1. Measurement equipment. Detailed accuracy equipment in the final rule. there's some very specific parameters. 2% within 1% of air density measurement, pressure measurement, very specific ambient conditions that the test method has to be tested under. There's a minimum sample size of 2 and sampling statistics. So isentropic efficiency is the lower of the mean of the test sample, which is 2, or the lower of the 95% confidence interval. And specific power, full load, actual volume flow, full load operating pressure, and pressure ratio are represented as the mean of the test sample. Manufacturers are required to publish the actual average performance values of 2 or more units with no adjustments. DOE has acknowledged that the proposed sampling plan may result in a more conservative rating than the current industry standard. Why compressor companies are not changing immediately? On the record from the DOE, the proposed sampling plan may result in a more conservative rating. In addition to being very time-consuming and expensive to test to the new standard, it would result in a significant reduction in published values across the industry. Why is this good for consumers? Requiring the use of sampling statistics rather than a sample mean provides end users and the DOE with reasonable assurance that any individual unit distributed in commerce is as efficient or better than its basic model rating. The end result, consumers receive units with the reasonable assurance that they match the published values. The energy conservation standards propose minimum efficiency levels over time, which will force lower performing models out of the marketplace. The final rule on the proposed efficiency level has not yet been published. It was originally scheduled to take effect 45 days after the December 2016 review period. Now, a coalition of 11 environmental groups, including the District of Columbia, New York, and have brought a suit in the Ninth Circuit Court to compel the DOE to publish the final rule efficiency standards. This is expected soon. While this is ongoing, California has moved forward with its own regulation. On January 9th of 2019, the California Energy Commission passed the energy efficiency standard with an implementation of 3 years. All rotary oil-injected compressors from 10 to 200 horsepower within the scope sold in California after January of 2022 will need to be tested according to the DOE standard, will need to be published in the California Energy Database, and will need to meet the energy level threshold. California level is currently TSL2. Here are some quick links for more information on the energy conservation standard and the sampling statistic. That concludes the initial portion of my presentation, and I will hand it back over to Tom.
All right. Thank you, Scott, for that overview of what's been going on with federal and state regulations, especially the advances being made in California. At this point, for all of our live attendees, and also those watching the webinar on demand, if you've got a question for Scott you'd like him to answer, please go ahead and type your question into the Ask a Question box, and we'll start getting to those questions right away. For those of you who are watching on demand, Scott can receive these questions via email. So, again, if you do have questions for him and you're watching on demand, rest assured your questions will get to him, and he'll reply to you as soon as he can. So, Scott, with that, we've got a couple already lined up. The first question is, where are consumers most likely to first see these new efficiency metrics show up in the market?
California has been taking the lead with a forced implementation date and very specific regulation on their own. So it is very likely that California is going to be the first market where these new efficiency standards and laws and regulations are seen in the marketplace by the average consumer.
Okay. Um, on that question too, I've got a question from someone on how to understand what they're looking at in terms of the published data. How does the consumer know if the data they're looking at is aligned to the new DOE standard or the California standard?
Currently, the current industry standard is to use ISO 1217, which allows for manufacturing variability in the published data. So there might be some tolerance, some manufacturing variability included in the statistic. The biggest change will be the publishing of isentropic efficiency, and the new DOE standard should be called out. And it might be in the form of 10 CFR, or it might call out the DOE a reference. Best thing to do is to ask if this is to ISO 1217 or if it's in compliance with the DOE regulation. In the presence of pressure ratio and isentropic efficiency is the first clue that you're likely looking at official compliant data with the Department of Energy regulation.
Okay. We got a couple new ones rolling in, Scott. So I'll ask one of the ones that just came in. This one is how does the state of California intend to enforce these new standards, or what kind of enforcement? I guess in general, Scott, what kind of enforcement oversight is there when it comes to these?
That's a good question. They have their own enforcement rules and laws. I mean, individuals with knowledge of compressors being sold in the marketplace after the implementation date will be able to report those if they're not in compliance. It'll be very clear from the website, from a consumer standpoint, which units are already registered and tested according to the law. So I think there's going to be more specifically coming as we get closer to that implementation date. But this is certainly not the first regulated piece of equipment in California. There's a lot of other industrial and energy-consuming pieces of equipment that are currently registered and enforced. So that would be my answer.
Okay, we've got another good question about what the compressor OEMs are doing, and you could probably speak most specifically to what Quincy is doing, but also if you've seen trends. The question is, what are the compressor OEMs doing internally to improve efficiency? And I'm going to add also, probably in anticipation of regulations like this.
Well, the first thing they're doing is trying to gather good test data for all of their existing models and plot or chart them in comparison to the new TSL2 efficiency standard. So the first thing those manufacturers want to know is, how do their current portfolio rank against the future efficiency standard profile, where models below that standard or below that level will no longer be allowed to be sold in commerce after a certain date. And then in addition to that, there's a lot of different things happening in the industry, from new core component design, new motor design, a lot of different technologies being tested and implemented across the entire industry. So, yeah, I think the regulation makes consumer manufacturers and OEMs aware of where they are currently, but I think everyone was already continuously looking for opportunities to improve the efficiencies of their machine. I don't know for manufacturers with top-tier efficiency that this put any additional pressure on them. As an example, my particular OEM brand, we don't have any models that are currently at risk of being below the efficiency standard. But I don't know the situation for other manufacturers.
Okay. Well, and it's a follow-on question for the European market. How confident are you that European manufacturers are going to follow the same new regulation in the U.S., and more generally, do you think they will?
I think they will have no choice unless they want to be sued or have some type of legal liability, because it will be against the law to sell a compressor in the state of California if it is not meeting the threshold and registered in accordance with their new laws and regulations. And I think that there will be a lot of self-reporting, and I think there will be a lot of pressure for compressors or brands that are not in compliance. I think the offenders, I think there'll be enough knowledge and information from sales and peers that if it's widespread or it's heavy, it'll be impossible to get away with for very long.
Okay. Okay. No, thanks for the answer on that one. This is shifting attention away from the compressors themselves to vacuum pumps. My question is, will the federal regulations apply to rotary vacuum pumps?
They've chosen not to include rotary vacuum pumps at this time. They've also, although they were originally considering pistons and oil-free compressors, they have chosen not to include those at this time. I would not be surprised if at a later date, piston compressors, oil-free compressors, or vacuum pumps were the next target on their list. But no, they are not included currently.
Okay. Okay. It looks like we've got 2 more questions lined up in the queue, so I'll invite everyone who's a live attendee today to ask questions in the Ask a Question box. And again, also invite those who are listening on demand to write your questions as well. This one, Scott, is on the food processing world or food manufacturing. What are the regulations for usage of air compressors, specifically food manufacturing? And I guess the question is there any special regulation that also would govern compressors just for food, or is the regulations applicable across verticals?
I personally don't have at the top of my mind the specific applicable food and beverage regulations by state. This presentation was very specific to the new regulations that just came down for efficiency standards. Okay. The new federal and California guidelines are very specific to isentropic efficiency, the new published DOE test standard, and the efficiency levels that were published in the Federal Register. So this is really about compressor efficiency, but not specific industry compliance like food and bev.
Okay. Okay. Well, we've got one more, Scott, and I think we'll move to wrap up. This one came in early, but I saved it for last. A good wrap-up question. What's the one takeaway, the one thing that you want people to know from what you covered today in order to put this information into use right away?
I think isentropic efficiency, according to the new DOE standard, equals transparency. So as an individual consumer, it is going to be more and more common that these values are published and they're going to be more reliable. So as an individual consumer, if you're getting a quotation or you're looking at technical data, it's good to ask if this is ISO 1217 or according to the new DOE test standard, and it's good to be comparing apples to apples because there is a difference in the accuracy requirements and there's a difference in the published values. And once you have 2 different entities both publishing to the standard with isentropic efficiency, it's very easy for a consumer to compare the efficiency of 2 different compressors at the same pressure.
Okay. Okay. Well, and you know what? I spoke way too soon, Scott, because even as we were covering this last question, we had a couple more roll in. So I'm game if you are. Sure. Tackle a few more questions here. Great. One of them involves older compressors being grandfathered in, and the question literally is, will these regulations affect the end users if they keep using older compressors?
It will not. Absolutely not. This is only applicable to compressors sold into this state in the instance of California after their implementation date. So anything sold up until that date does not have to comply, but anything sold after that date needs to be published, uploaded to their website, and published and tested according to their according to the test standard in accordance with the publishing guidelines.
Okay. I actually think that takes care of one of the other questions, but I'll read it anyway. Does the law require that existing compressors that are in place and below the efficiency standard be replaced with new models?
It does not, but I expect it will bring additional transparency to the market. People will be able to utilize, if their existing compressor were illegal to sell after that date, then that might bring additional awareness that their particular compressor is quite inefficient. And it might start a conversation about if they voluntarily chose to upgrade that to a newer or different technology, what would be the payback? What would be the return on their investment? It might help them to start that conversation. But there will be no forced purchase or forced conversion for older models that are under the test standard. The customer will just have to pay a much larger electric bill as a result of having a very inefficient machine.
Okay. Good question then. Stationary versus portable compressors. Are these standards exclusive to stationary compressors, or do they also cover portables as well? And if not, are portables being looked at?
These are exclusive to electric driven, and most portables, although some electric driven can be portable, but the typical use of a portable is a tow behind, which usually is diesel powered. So portables in the sense of a gas-powered unit are not as part of the regulation. And, of course, just like oil-free, just like piston compressors, those could be next on the chopping block, but they are not currently included in the current test standard.
Okay. And then a follow-on from the same person who asked, and this is a really interesting one. Do you think that this will continue on a state-by-state basis, or do you think it's more likely that the California regulation will eventually become the federal regulation?
That's a good question. So I do not believe it will continue indefinitely on a state-by-state, because California's law is really after the federal law. So one thing to understand is that there is currently a federal law regulating compressors, which was before California. It's just not yet fully being enforced, because the final guideline, which was proposed but not published, the final efficiency standard, the efficiency tier, that because that was not published, the federal regulations essentially is on hold. There is multiple lawsuits in the courts where this is being worked out. I believe eventually that the DOE will publish that, and then it will be universal across the entire United States instead of just in California. Both the California and the federal have a lot of things in common in that they follow the same federal test procedure with the same publishing guidelines. So they're a lot of similarities and a lot of common. In fact, California uses the federal rule, the federal law, as a premise for pushing forward while the DOE has paused and not moved forward at this time.
Okay. And the same person that's following while you were speaking, the question simply is that Tier 4? And I confess that you both have more knowledge about what that question implies than I do. Does that make sense? That question is that Tier 4?
Yeah, a lot of times that has to do with, for instance, diesel compressors or diesel engines. So there's multiple, Tier 1, Tier 2. So no, this is not the same thing as Tier 4. There's basically by flow or by CFM, there is let's just say 100 data points where you can plot a graph based on CFM and based on 4 different efficiency levels. And there is a formula where you could take your existing data, existing unit performance, and you could calculate isentropic efficiency. It's actually included in one of the handouts for more information. So if you wanted, you could use, here's another important thing. You can use existing ISO 1217 data to calculate isentropic efficiency. but you need to ask, does that ISO 1217 data, unless it's raw data, have manufacturing variability? The answer is likely yes. What makes the DOE unique is that they require very specific accuracy of the instrumentation over a specific sample time frame, and they require you to publish the average of raw data, no statistical adjustment. That's the biggest difference between old ISO 1217 and the new DOE regulation, is that you're using very accurate raw data with no adjustments allowed. It makes the published value more repeatable, more accurate. So if you're measuring your actual machine performance, you will get a very accurate isentropic efficiency, which is also what you'll get when it's DOE compliant.
Okay. It's another question from this questioner. What are some of the core components that are being targeted for efficiency?
All the obvious ones: controls, motors, the full drivetrain, air ends, almost everything on the air compressor: motor, gearbox, air end, unloader, controller, piping, coolers, discharge, various types of regulation within the compressor. Everything on the air compressor is up for being targeted as an opportunity for improvement.
Okay. And then we have a question on the relationship between this and KGI efficiency standards. The question is, will KGI efficiency standards be valid after 2022? And what's the relationship there?
Currently, there are no KGI efficiency standards. Currently, KGI tests and publishes with all of their members to ISO 1217. And that's currently the standard that they're on. I imagine as DOE and laws change that they will update their own test standards and work with their members to update things as the market demands it. But KGI is a trade organization that follows an ISO standard, an international ISO standard for testing compressors.
Okay. The more we dive into the topic, Scott, the more questions we're generating. So we have another one. Is there a target percentage for efficiency improvement?
I believe that the DOE had some very high-level figures in their published regulation of how much energy and how much improvement that they thought over a 10-year period this would bring. Specific to any model number, it really depends on the technology. So the short answer is no, but not from a compressor company standpoint. But the DOE did have and has published some expected efficiency gains that they believe the entire market will benefit from as a result of their regulation.
Okay. Well, I think with that, Scott, I mean, we can wait a second here to see if other questions roll in, but we have got the last of the questions that were coming in live. So with that, we'll move to close out, I guess. I'd like to thank everyone who attended, and Scott, thank you very much for presenting with us today.
Thank you. It's been my pleasure.
And I'd also like to thank our sponsor today, Quincy Compressor, for making this webinar possible. This webinar has been recorded and will be available shortly for on-demand viewing. You're also encouraged to visit plantservices.com to gain access to even more tools and resources aimed at helping you achieve success. The full set of speaker slides from Scott's presentation today will remain available for on-demand viewers in the handout area at the lower left, as well as the white paper he mentioned on isentropic efficiency and specific power. And those of you listening live have about, I'd say, 30 more seconds to go to that area. You can go ahead and do your downloads right now. Did you like this presentation? Please let us know your thoughts by answering our brief survey that will appear on your screen once this webinar is closed out. Your candid answers are not only appreciated, they help us craft future and better events. So once again, thanks to Scott for presenting, thanks to our sponsor, Quincy Compressor, and thanks to everyone for attending with us today on Live Day. Have a great rest of the day.